So if we do some manipulation to our product to sums, we will end up with our sum to product formulas, which can be verified by using the previous set of rules in the previous video. But here we are. There are times where we will need to write sums as products, as you see when we verify an identity in this video. These are the rules, and these rules are going to be given to you on the formula sheet. And it's a way to take a sum or a difference of either cosines added or subtracted, or sines added or subtracted. There's no combination of sine and cosine in this one. So a simple example might look like this, and on the test you might be asked to just express as a, let's see, express the sum as a product. So that tells you got to use your sum to product rules. So let's suppose I had sine 9x plus sine 5x. Well, let's identify our alpha is 9x and our beta is 5x. So we're going to apply that top formula because it's sine plus sine. So it's just simply going to be 2 sine of 9x plus 5x over 2 cosine of 9x minus 5x over 2. Now, 9x minus 5x is going to yield a positive number, but do apply those even odd rules if you get a negative. So that's going to give me 9 and 5 is 14. 14 divided by 2 is going to give me my 7x, 4x over 2, 2x. So the answer simply comes to 2 sine 7x cosine 2x. So ultimately, you apply the correct formula. Only should take you a minute or two to do one of these problems. But they are also useful in verifying identities. So let's take a look at that. And we want to verify the fact that cosine 3x minus cosine 5x over sine 3x plus sine 5x actually equals tan x. So you can see our left-hand side is quite complicated and our right-hand side is very simple, so we're not going to do anything to the right-hand side, but we're going to focus on that left-hand side. Yeah, these clearly look like sum to products because you have this sum or difference, and we know if we can get just a sine and just a cosine, we have a tangent. But to get that, we've got to first get the sum and that difference down to a product. I'm going to apply it. All right, cosine minus cosine. So the first one I'm going to apply is this one right here. That's the one that starts -2. So to apply that, I'm going to get to my numerator. It's -2 sine of alpha plus beta, 3. I'm going to write them together and make that an 8x. Save ourselves a step here. And then sine 3x minus 5x -2x over 2. So let's just double check. Yep, it's sine of them added and then sine of them subtracted, which is what I did here. Okay, but my numerator is sine plus sine. Well, that's the one we just worked on. It's sine added cosine subtracted. So that's 2 sine of 8x over 2 cosine of -2x over 2. All right, so let's deal with these. There's a lot of things to do here. We can simplify. We can do that real quick. There's a lot of things we can simplify. The 2's can cancel out front, so that's just a negative. And I have sine 4x sine -x, right? -2x over 2. The 2's canceled, so I have sine 4x cosine negative x. I'm going to simplify it some more. Well, the sine 4x's go away. So I have negative sine negative x cosine of negative x. But I can apply that even odd. Sine is an odd function, so the negative moves out front. So I have negative sine x. But cosine is even, so it kind of gets absorbed and does not move out front. It just becomes cosine of x. Negative times a negative is sine x over cosine x. And remember, we just needed this to equal tan x. So tan x, and there is our right-hand side done. And it is verified. Okay, so there's one of the verifying problems we can do. That is it for all of our formulas. The last video that you will see in this section next week has to do with actually solving trig equations. We get away from verifying and moving to solving.